Hi, welcome to review for Chapter 3. Now this video is just on question 3.1 and that's in your textbook, page 202. Okay, so let's get started. I read through the question here and it says born to be old. So take a minute to just pause the video, open up your textbook, look at the question here. There it is. And we see some data. So as we're looking at the data, it says gestation in days as the X, or the explanatory, and lifespan is our response variable. And this is an interesting one because it's really highlighting these point A and point B. So let me realign my camera here. So how would I write this out? So make sure anything you turn into me, you put your name, date, and period. And I'm going to make just a quick sketch of what they seem to have going there. So I'm noticing the dots look something like this. And again, this is gestation period in days. And this is lifespan in years. So up here we have a point A, and kind of over here there's 2 points and there's a B over here. So it looks pretty obvious that there may be 3 outliers, this one, this one, this one. And if you've been looking in the book or going over the video, all outliers are not created equal like in Chapter 1. In Chapter 3, there may be some different reasons. So we're going to analyze these. So question 1, though, starts out right off our script. It says, 1A says, is there a relationship between the gestation period and the lifespan? So if I look at, is there an association? And we're going to go just right into our script here, and that's our LSD. So there is a, or backwards. So it looks like the dots are pretty well clumped together, and if I made a line, maybe I'd make it about here. Okay, something like that. So that looks like my line of best fit. As many dots above as below. I am a little worried though. So with these outliers, I am a little worried that maybe when I made that line of best fit, just kind of guessing, I was kind of ignoring this. So when I look at this to myself, I think, well, if I do see how big that square would be with A, that point A would almost drag, it doesn't look like it would make it more flat or more steep, but it does look like it would drag the whole thing up to meet it. Something like that. Maybe I went a little too far, but you get the point. Maybe I'm exaggerating. So my new line is being dragged up to get B, to get A. But when I look at B, it looks a little different. B kind of looks like it is extending my line. It may make, it might tilt mine a little bit trying to get to point B. So maybe it would increase my slope to get to B, because definitely these are going down. So let's take a look though. Let's just say with my line, with either of my outliers here, I still believe that there is a moderate, positive, right? I need my direction, and linear relationship between, and this is right off my script, my X value and my Y value. So between gestation period and lifespan. Now there are answers to these questions in the back of the book, and I'm just kind of explaining it. I'm not really going astray from what those answers might say. Now if I looked at this without outliers, totally ignoring these, I actually noticed that these dots, if I zoomed in, might kind of make a frown. So what I'm saying is maybe it's looking something a little bit more like that. If I didn't have A, B, or this other dot, maybe these dots would look a little curvy. And so the answer in the book talks a little bit about that, and they just say that without the outliers, definitely the dots would be closer. Definitely the dots would be closer to the line of best fit. So I believe that the association would be moderately strong. So I think that my strength would go up, positive, and curved. So I actually think it might not be linear if I were to ignore the other dots there. Okay, now let's get to part B and C. So they ask, how does point A in the hippo, that's our hippopotamus, because these were 43 animals, how does part A affect R, affect the least squared regression, and affect S, which is really just the standard deviation of the residuals, or what you also might think of as a typical prediction error. Now, remember the line of best fit is my predictometer. So A is way off my prediction. The residual is just the distance a number is, whether it's under or above, the distance it is from the line of best fit. And so all the residual is the distance a number is from the line of best fit or from your prediction. And so that's how far off your error would be. And we could find the standard deviation or the amount a typical prediction would be off. And that's what S is. It's the standard deviation of the residuals. So let's think about this for a minute. When I look at point A, if R tells me how close the dots are together, so when the dots are really close to the line and all the dots are close to the line, R approaches 1. Then I can say to myself, oh, wow, okay, A definitely does affect that. So I'm going to say R ranges from 0 to 1. With point A included, R would decrease. Because it is far away from the least square regression line. Okay. Now, how would B affect R? So if you notice how we extend even the green line or the orange line, B actually ends up landing on there. So this is very different, where B, point B, when included, does not affect R as much. Because point B actually, if I extend my line of best fit, would fall close to the line, and A is way off. Now let's see, how would these points affect the least squared regression line? So if I look at my least squared regression line, I think we've already answered this, but it's good to think about this. These are the reasonable values of X. This is where all my dots are clumped. And look, A actually falls right in the middle of there. So A, the hippo, actually has pretty close to an average gestation period of any animal. But if you look in the Y, it has a much longer lifespan. So if you look at the book's answer to this, that might help it make sense. It says A is close to X bar. That's just the average gestation period. And because of that, it won't affect slope as much. However, like we said in the green line, it will affect my y-intercept. So the entire line will move up to meet it. So what happens is see how the y-intercept, but will affect the y-intercept. Okay. Now as we look at, well, how would point B affect it? And as we stated there, the orange line, B, if included, may increase the slope. That's the tilt. So it does look like we may have to tilt it up to grab that number. It may increase the slope, but it might not affect the intercept as much. Okay. And then how would this affect S? So this is the standard deviation of the residuals. So kind of like we said here, when A is included, it would affect S because point A has a high residual value. And that is the standard deviation of the residuals. Point B being included will have a small residual because point B actually ends up landing near the line. So we'll have less effect on S. Thanks for joining us. Check out the next video to learn more.